Today, we're going to build a playable musical keyboard on a web page. Why this exercise? Well, I wanted to pick something where we can exercise both the code writing ability and the domain knowledge of our AI tools. So in order to complete this exercise, we need to understand something about what a piano looks like, how pitches work, as well as how to implement these features on a web page. We're going to set some constraints for this exercise. No framework, no imports, just a single .html file viewed in a browser. Let's begin. Okay, we have an empty directory and nothing in it. We're going to make a new file called index.html, and we will open that in VS Code. So I'm going to open that project. I'm going to make this a little smaller so we can balance what we're looking at. And we will ask ChatGPT for some help. So what we're going to do, well, actually, we can probably just ask Copilot for help. Let's see, basic HTML structure. Let's see what we get. Okay. Yep. Okay. We're going to ask for a body. Yep. Okay, so this is mostly correct. I don't actually want a separate CSS file. We'll just drop it directly in here. We'll make a style tag. Is that a thing? Okay. And then down here, we'll make a script tag for the JavaScript. Yeah? Do that. All right, we'll start with an H1 piano. All right. Now, if I look at this file, I can open this file. If I just open it, I believe it's going to try to open it in, in Chrome. So here we go. We've got a Chrome window with now two tabs, ChatGPT over here with nothing in it so far. Notice I'm using GPT-4. Here's the web page. And what we'll do is we'll start asking ChatGPT for help. So I want to create a single web page that displays a playable piano. Let's start by writing a user story. As a type of user, I want an action, so that benefit, okay. As a music student or composer, I want to interact with a playable piano on a single web page so that I can practice scales, chords, or test out melodies quickly without needing an actual piano. Yeah, that's pretty cool. I think that's going to do it. I'm going to make a, let's make a section up here that's just, like a README. But since this is a single page, we'll just do it this way. All right, and there's some acceptance criteria. Graphical representation of a piano keyboard is displayed. User can click on individual keys to produce corresponding piano sounds. Keyboard should support multiple simultaneous key presses for chords. Nope, that's not going to happen. Sound produced should have minimal latency. Yeah, okay. Well, we're going to change that. I'll want the keys to play on rollover and stop any previous tones when the new one starts. Okay, when a new one starts. That's a good, okay. Thank you. I'll want the keys to play on rollover. Okay, great. All right, accepting, updating the acceptance criteria. I don't care too much. Write a DOM structure for a 2-octave keyboard from C3 to C5. That is the C below middle C to the C above middle C. Let's see what we get here. ChatGPT is pretty good at creating things out of whole cloth. Copilot is better at finishing thoughts, right? If I start to type into the code, but I believe this will give us better results. Okay, it's going to give us the whole list. We don't need the comments, so what we'll do is probably wait for it to finish. We'll copy the DOM that it gave us and drop it into our thing. Then I'm going to do some adjustments based on my domain knowledge, and we'll go from there. So we've got A4, B4, C5. Okay, it's done. Okay, so what I'm going to do is try to take, I wonder if I can collapse. No? Okay, I'm going to take just this structure. We'll take that. We'll drop it into the body right here. And we'll call this keyboard. All of these comments, I really don't need them. So I'm going to ask it to remove those. Or I'll just do it. Sometimes there's just some grunt work to do. I could ask ChatGPT to revise without these comments, but earnestly, by the time I did that, I could have done this simple task. So I will do it this way. I could also have done this with a regex. I'll do it this way. Now, I'm going to organize these into octaves. So I'm going to say, class equals octave. And I'm going to say data octave number is going to equal, we'll say 3 here, right? Because that's the octave. So do that, and I'll drop the first octave of keys into that div. All right, this is just for my own benefit. I'm going to say, instead of data note, note is an overloaded term in music, so we're going to call this pitch class, and then remove the octave number. That, and I accidentally added that as well, so I'm going to put that back in. Now we can get the number from the octave number from the parent, so that's fine. So I'm going to take all of this. I also don't need dash key. These are a bit redundant, so I'm going to do that. And then I'm going to duplicate this and call this octave number 4. And then I'm going to duplicate it one more time and delete all the keys except for the initial C. Or even just, how about these? And close the div. So what have we got? We've got a keyboard with 3 octave children, and then this is going to be 5. Okay, now I'm going to give ChatGPT my DOM that I've created. Okay. Thanks for the draft. Here is what I wrote. Okay, so what we're going to do next is take a look at this page here. Now, these are just a bunch of empty divs, and they have no visual appearance. If we look in the if we inspect the page source, we'll see that these exist, like they're in there. Keyboard, octave, octave, octave. There's these keys. That will make it easy to select and manipulate keys using JavaScript later on, and it simplifies the task of playing. Yeah, I agree. Okay, so would you like to move on to the JavaScript functionality? Let's do the CSS styling first. That was very savvy of it to understand what the 2 next tasks are. Let's do the CSS styling. I want it to look like a piano with the appropriate key dimensions. Dimensions is with an S? Okay. Let's see what it comes up with. Now this is tricky, right? Because the LLM needs to understand what a piano looks like and then understand how to create that that physical reality in CSS. So we will take all of this. So we do have ID keyboard. Interesting. I thought I had said class keyboard, but it's ID keyboard, which is probably better. So what I'm going to do is just drop this in here. Was it finished? I believe it was finished. I'm going to paste this in. So, okay, so we've got keyboard, black, hover. Okay, we've got these hovers. So it looks like it even changes the styling on hover, which is really lovely. Okay, ease. Oh, there's a little ease pointer, transition background color. Interesting. It takes 0.2 of a second for the key to be pressed. That's pretty cool. It's probably too slow. I'm going to decrease that, increase the velocity. So, all right. So I suspect that it has not nailed it right away, but let's take a look and see. Oh my goodness, that is basically perfect. I'm going to say, this is great. I'm going to say margin, 1 rem, auto, so that it will center the keyboard. Let's see if we can get width. We'll say fit content. I think that will do the job. Yeah, there we go. Okay, and then I'm going to make the background, let's just style the body. Background color, yeah, let's make it kind of a darker, sure, fours all around. All right, so if I do that, we don't have background color. Oh, it's not dot body, it's body. It's just a body tag. Okay, there we go. There's our piano. Beautiful rollover effect. Okay, and I'm going to style H1 to color, yeah, align center color F. So sure, that sounds pretty good. All right, so that's not terrible, right? Let's even say font family. Well, let's just do a sans serif. That's all we'll do. We won't specify. Okay, it's not entirely perfect. We can tweak the visuals. This is a really strong start, though. How did it place the black keys? Let's see. With a Z index, that's really lovely. Okay, so this is almost perfect. One of the things we'll need to adjust, if we look at, let's go to images, let's just go to Google. We'll go to piano keys, and we'll look for images. And what you'll notice is that most of the examples are the way that it designed it for us. The black keys are centered between the white keys. You know, notice how narrow this little white strip between the black keys is. That's not how a real piano works. A real piano has room for your finger between the black keys. So this one is actually accurate. And now notice that the C sharp is leaning towards the, it's more on the side of the C, the D sharp is more on the side of the E, etc. So we're going to ask it to make that correction and see if it can. I'm going to close that back up. Now, on a real piano, the C sharp is 2/3 on the side of the C and 1/3 on the side of the D. Can you make adjustments for C sharp, D sharp, F sharp, and A sharp? Okay. Let's see what we get. It looks to me like it's maintaining the bulk of the existing styles, and it's probably going to add some additional specificity here for the particular black keys. I love it. Okay, so it didn't change anything. It didn't need to give me all of those styles over again, which is something it's usually pretty good at. But we've got some specific adjustments. These look pretty great, actually. Let's do that. So we're going to say this. So notice not only did it give me a good starting point, but I'm getting pretty good adjustments based on my feedback. And I told it the ratios, so maybe it's using that, but maybe it's also sort of aware. Okay, that is brilliant. That is like perfect, basically. I don't love that there's a little bit more gap between some of these, and I wonder if we zoom in, whether that's an illusion. No, probably not. I think it's because there's, between the E and the F and the B and the C, it's looking a little close, but I'm going to live with that. So we've got a perfect displayed keyboard here. So now, yes, let's write the JavaScript. And diving in, we'll see if it starts strong here. Attach a mouse hover event to the piano keys. Stop any currently playing sound when hovering over new key. Play, I'm glad I specified that. Play the sound corresponding to the hovered key. Okay, so one of the things it's going to need to know here is, how does this work? How do pitches work, right? If you think about every key on a piano plays a different pitch. And they have a certain relationship or ratios. And there are standard tuning methods. A440 is the reference pitch. That's the A4 is 440 hertz is the standard. And all of the other keys are essentially in ratios from that reference point. So we'll see if it gets this right. So we're going to just read through it a bit. It says, okay, add event listener, audio context, current oscillator. Okay, we've got this keyboard, so it's gotten the keyboard, and it's going through the keyboard and saying, give me all the keys. Okay, classless, if it contains key, all right. Current oscillator stop, okay, get note information. There's the octave number from the closest octave. That's brilliant. Okay, pitch class, note, frequency. Okay, calculate frequency. Interesting, I'm curious about that. So it's passing in the note. That's odd. What is a note? Okay, it's apparently a string that has the pitch class and the number. It's probably going to split it back out. This is not great. I think what I want to do is ask it to revise that. So keyboard, set event listener, mouse out, stop. Okay, love it. All right, so I'm going to take this whole thing, copy it, and paste it into my script. And then I'm going to indent that because that's going to drive me crazy if I don't. We've got a bunch of complaints from ESLint, but DOM content loaded. I wonder if that's even a thing. Let's load the page and just sort of see how broken it is. Go to the console. Okay. Uncaught. Failed to execute stop on that. Okay. Yeah, let's see if we can cajole it into fixing this. So I want to say, instead of note, I'm going to say pitch class and octave number. Yeah. And then we're going to say, yeah, we're not going to return from a structure. We're actually going to do the math. Let's see if this is code, this is Copilot. Octave offset, okay, octave number -4, okay. All right, note offset. Note offset's pitch class. Okay, so is that a thing in here? We don't have this. Total offset, okay. Times 12 plus note offset. Base frequency. What is the base frequency? We don't have that here. So and then we're going to multiply it times some number. I have a feeling I understand what it's trying to do here, which is note offsets are going to need to be a data structure. So we're going to say note offsets equals, let's see if we get, yeah, okay. Yeah, in fact, this could be the index, of this would give us the offsets as well. So let's just say pitch classes. This is going to be a const, and we will just take all of, yeah, let's just do, if I start typing this, I suspect I'll get all the rest. D, okay, great. So there's all the pitches. Instead of note offsets, we're going to ask for note offset equals pitch classes, pitch class. So this is the index of how do you get that in JavaScript? Something like this. Index of pitch class. Sure. Okay. So total offset is octave offset times 12 plus. Okay, now the base frequency is probably, it looks to me like it wants to be C0 because we're doing that. So C, we're going to say pitch of C0 equals, we're going to make a const and just see if Copilot will give it to me. There it is. That is probably accurate. C4 is about 261. So divided by 8. Yeah. So yeah, that's going to be pretty darn close. So we're going to add that up here. So this is not the pitch of it, it's the frequency of C0, and we're going to use that as the base frequency. That, okay. So now we have calculate frequency with a pitch class and an octave number. I'm going to come back up here and just say, we don't have a note. That would be called a pitch, by the way, not a note. A pitch class with an octave number is a pitch. It's a named frequency. So the frequency is going to be pitch class, comma, octave number. Okay. Now, sine wave, okay, start. So the thing we were having crash on us was something else, but let's see if we can. Okay, so they're all very low frequency. I hear it coming through my speakers, but it's like a sub-audial frequency. So this isn't quite right. At this point, I had to take a few minutes to do some debugging that I don't want you to have to suffer through. It turns out I had carelessly mixed logic from my conversation with ChatGPT with the new approach I took with GitHub Copilot. Something to look out for sure. In future videos, we could explore the value of agile methodologies. This particular moment really drives home how test-driven development ultimately saves us time. A unit test for our calculate frequency function would have immediately caught the math error, as would, more than likely, pair programming. Zeros all across. All right, so -4 doesn't seem to be doing it. Well, 0, okay, so 0 would make sense for the octave offset. Oh, we don't need to subtract. If we're saying -4, then actually the reference pitch would be middle C. That was my mistake. So octave offset. Okay, so what I can do is say frequency of middle C, and I'm going to delete this and let Copilot fill it in for me. Yeah, 261. All right, so I'm going to take this and drop it as our reference frequency, whereas pitch of middle C, which is C4. Okay. I think that was our whole problem. Complete. Okay. Thank you for following along. You can do the same on your own with ChatGPT and Copilot.